Oxygen levels critical. In a groundbreaking revelation, leading astrobiologists suggest that the Viking landers may have stumbled upon evidence of microbial life on Mars half a century ago. Paradoxically, the very experiments designed to uncover this life may have inadvertently destroyed it. We know that Mars was once geologically active and rich in geochemistry. It also had liquid water about 3.8 billion years ago, around the same time life was taking root here on Earth, possibly under even more favorable conditions. Since Mars shared many of the environmental factors that allowed life to arise on our own planet, it's plausible that life may have emerged there as well. Today, we seek evidence that life once existed, or perhaps still exists, on Mars. There is strong evidence that not all of Mars's water escaped into space, raising the possibility that Martians, microbial or otherwise, could either remain there today or once thrived in the past. Mars, now a barren and arid world, might still harbor unique drought-resistant microbes adapted to the red planet's dry environment. Some scientists propose that these organisms could use hydrogen peroxide internally, enabling them to extract water vapor from the Martian atmosphere. During the Viking missions, several experiments were conducted to detect signs of Martian life. One approach involved adding water to soil samples, based on the assumption that life there, like on Earth, would require liquid water. Ironically, if Martian microbes had adapted to extremely dry conditions, flooding them might have been lethal. Another experiment involved heating the soil, potentially burning any organic compounds, especially if Martian life contained hydrogen peroxide within its cells. The cruel twist is that our attempts to find Martian life may have annihilated it before we could confirm its presence. This unsettling possibility forces us to ask, if we did encounter life but failed to recognize it, how should we adjust our strategies for searching for life elsewhere, such as on distant exoplanets? When it comes to intelligent life, any discovery on Mars would likely be of microbial forms. Still, considering the immense scale of the universe, 400 billion suns in our galaxy alone, and trillions of galaxies beyond, logic suggests civilizations must exist somewhere out there. The question is, how far away and how rare are they? The timeline on Earth suggests that developing a civilization took nearly 4 billion years. If this slow progression is typical, then advanced societies might be few and far between, possibly leaving our galaxy with a mere handful, maybe only one, ours. Uncovering even microbial life on Mars, especially life with a biochemistry different from our own, would revolutionize how we search for life on exoplanets. It would broaden our perspective, challenge our Earth-centric assumptions, and inspire new innovations in astrobiology and space exploration. In related news, NASA scientists have identified a potentially vast ocean on the exoplanet K2-18b, about 120 light-years away in the Leo constellation. Thanks to the James Webb Space Telescope, we know this Hycean world, roughly 9 times the mass of Earth, may have a hydrogen-rich atmosphere overlaying an oceanic surface. Even more intriguing is the possible presence of dimethyl sulfide, a molecule produced solely by life on Earth. Worlds like K2-18b, bathed in hydrogen atmospheres and harboring deep oceans, could teem with life, from simple microbes to complex thriving ecosystems. If the universe is teeming with life, potentially even advanced civilizations far older and more sophisticated than our own, why have we not detected them? This question leads us to the Fermi paradox. If civilizations are likely, why don't we see any evidence? With so much time having passed, over 13 billion years since the galaxy formed, if other civilizations emerged millions or even billions of years ago, they should have left their mark. In a mere 500 years of scientific advancement, humans have ventured beyond the solar system with probes and set foot on the moon. Imagine what a civilization 1 million years ahead of us could achieve. They might have spread their presence clearly across the galaxy, yet we see no obvious signs. Our quest for intelligent life now turns toward searching for techno-signatures, indicators of advanced technology on distant planets. These could range from the chemical fingerprints of industrial byproducts in their atmospheres to colossal energy-harvesting megastructures like Dyson spheres. Discovering such techno-signatures would confirm not only the existence of other technologically advanced societies, but also challenge our sense of uniqueness and prompt renewed curiosity, cooperation, and ambition in our cosmic exploration efforts. Future missions may directly image Earth-like exoplanets, and by the end of this century, we may finally detect life on distant worlds. Once we identify it, we can study it further, learning about its nature, technology, and behavior. Only after gaining this understanding should we consider making contact, an approach we hope any advanced civilization would similarly take with us. The stars act as mirrors, reflecting our hopes, fears, and aspirations. When we imagine advanced alien civilizations, we often project our own future potential onto them. We have the chance, if we avoid self-destruction, to become one of these advanced civilizations, to reach out across the galaxy and engage with others. Yet, as physicist Brian Cox has suggested, it's possible Earth may be the only island of meaning within our galaxy of 400 billion suns. If that's the case, our existence and the value we place on it become even more significant and humbling. Still, with an estimated 2 trillion galaxies, it seems improbable that life and civilization haven't arisen elsewhere. They may simply be scattered thinly across the cosmos. As our understanding of life's complexity and technology's reach evolves, our search for extraterrestrial life has only just begun. The grand expanse of the universe awaits our exploration, and the answers we seek about life's origins, frequency, and nature may be found among its countless stars.